For 8 episodes, we have measured the chaos of the present. Today, we conquer it. We move from measuring data, to predicting the future. This is linear regression. Imagine mapping data on a grid. The x-axis is hours spent studying, and the y-axis is the final test score. The data looks messy, but our brains can clearly see a trend heading upward. To predict future scores, we need to draw a single line through this chaos. You might remember the equation for a line from algebra, y equals mx plus b. But out of infinite possibilities, which line is the absolute best? If we draw a random guess, we can measure exactly how wrong it is. We draw vertical lines from the actual data points to our guessed line. These are called residuals, or errors. To find the perfect line, we take all of these errors and mathematically square them. This heavily penalizes large mistakes. The line of best fit is the one that minimizes the total area of all these squares combined. The ordinary least squares. But how does a computer actually find that exact lowest point? Let's step into the third dimension. We can map the slope and the intercept as a 3D landscape, where the height of the surface represents the total error. Because we squared the errors, the landscape forms a perfect bowl. Machine learning algorithms use a process called gradient descent, mathematically rolling a ball down this slope until it hits the absolute bottom. The minimum error. The perfect line. By finding the bottom of the bowl, we find the line that perfectly predicts reality. Next time, we bend the line to classify data with logistic regression. Thanks for watching.